Auzubillahi minash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Assalamu alaikum, dear students. Welcome to week number 14, recorded lecture number 38. Well, today we shall be continuing ethical problem solving techniques that we started in the last recorded lecture. So, this is the second lecture on ethical problem solving technique. So, let's start. So let's begin with the steps in resolving ethical dilemmas. Number one, reasonable solutions to ethical dilemmas are clear, informed, and well reasoned. Right? These three characteristics. Now, clear refers to moral clarity. Of course, our focus is morality, not technical part. So, in this course, clear refers to moral clarity. Clarity about which moral values are at stake and how they pertain to the situation. It also refers to conceptual clarity. Right? First, moral clarity. Second, conceptual clarity. Precision in using the key concept or key ideas applicable in the situation. Informed means knowing and appreciating the implications of morally relevant facts. So, knowing and appreciating both. Next, in addition, it seems being aware of alternative courses of action and what they entail. So, what are alternative solutions, moral solutions of that case? Well reasoned means the good judgment is exercised in integrating the relevant moral values and facts to arrive at a morally desirable solution. So, in order to be well reasoned, we need to have good judgment, and we implement this good judgment and integrate it with relevant moral values and facts to arrive the moral justifiable solutions. Alright, so let us have another case. This case is of a chemical engineer. A chemical engineer working in the environmental division of a computer manufacturing firm learns that her company might be discharging unlawful amounts of lead and arsenic into the city sewerage or sewer. So this lead and arsenic most probably are some chemicals. The city processes the sludge, or we can say close related mud word for that, into a fertilizer used by local farmers. To ensure the safety of both the discharge and the fertilizer, the city imposes restrictive laws on the discharge of lead and arsenic. Right? They set some limit that up to this level it can be discharged into the sewerage water, so that the fertilizer and the farmers who use that fertilizer, it does not become harmful for them. Primarily,
investigations convince the engineer that the company should implement stronger pollution controls, but her supervisor tells her that the cost of doing so is prohibitive and that technically the company is in compliance with the law. She also scheduled to appear she is also scheduled to appear, the engineer, before town official to testify in the matter. So the problem is, what should she do? She means the engineer. So she wanted to control, but her supervisor says, well, the cost to control is too much if they actually control, but they are meeting the government criterion, so technically there is no problem and they can go ahead with that amount of the liquids being poured into the sewerage of the city, and technically they are right. And the engineer is now called to the town official to certify that the amount of chemical being put into the sewerage is according to the standards of the city government. Now let's talk about the clarity. We have discussed in today's lecture in the beginning a few factors, steps that can help resolve a case. So the first among them was clarity, and within clarity we can have more than one types of clarity. So one, we have moral clarity. Moral clarity identify the relevant moral values. The most basic step in confronting ethical dilemmas is to become aware of them, right? The first thing is we become aware of the moral dilemmas. Only then we can go to the next step of making decision. This means identifying the moral values and reasons applicable in the situation and bearing them in mind as further investigations are made. So for further investigations we need to understand these basic moral values. If we don't know them, maybe we cannot go ahead with the further investigations properly. These values and reasons might be obligations, they can be rights, they can be goods, they can be ideals which might be desirable but not mandatory, or other moral considerations. So these all moral considerations should be in our mind when we go for solving a moral dilemma. Now further on moral clarity, exactly how we articulate the relevant values reflects our moral outlook. How we look at them, how we perceive them, that shows our moral outlook. Hence the moral frameworks discussed earlier are relevant even in stating what the ethical dilemma is. The 5 moral or ethical theories that we covered in the last week lecture: utilitarianism, duty ethics, right ethics, virtue ethics, and self-realization ethics. So these moral frameworks, if we have understood them, they will help us understanding the dilemma. Another resource is talking with colleagues who can help sharpen our thinking about what is at the stake in the situation. So maybe being fresh engineer, you may come across some problems for the first time. So the first source, the moral framework can help you. Secondly, you should talk to the colleagues who are relevant to your field and they may have come across similar dilemmas in their practical life, so discussion with them can be helpful. And third one, but the most useful resource in identifying ethical dilemma in engineering are professional codes of ethics as interpreted in the light of one's ongoing professional experience. So we will cover professional codes of ethics in the next week lecture. So then it will be clearer to you what do we mean by this. Now, like most codes of ethics, the Code of Ethics of American Institute of Chemical Engineers, because we are studying the case of chemical engineer, indicates the engineer has at least three responsibilities in this situation, in this particular case. One responsibility is to be honest, like issues, statements, or present information only in an objective and truthful manner. So the code requires chemical engineer to be honest. A second responsibility is to the employer act in professional matters for each employer or client as faithful agent or trustee, avoiding conflict of interest and never breaching confidentiality. So this is that the engineer should be loyal to the employer or to the client, and should be faithful faithful agent to both client and employer. A third responsibility is to the public and also to protect the environment. So hold paramount the safety, health and welfare of public and protect the environment in performance of their professional duties. So in this particular case, these three codes of ethics from American Institute of Chemical Engineers, because the engineer is a chemical engineer, they are appropriate and the engineer should know and follow while making the decision. In the case at hand, the members of the public most directly affected are the local farmers, of course, because they get it directly. But the dangerous chemicals could affect more persons as leads and arsenic are drawn into the food chain. Of course, farmers use that for farming different types of food, that indirectly the entire food that is produced there can have these harmful effects, and which ultimately can negatively affect those who use that food. Additional moral considerations not cited in the code include duties to maintain personal and professional integrity and rights to pursue one's career. So, though they are not explicitly mentioned in the code, but again it's the duties to maintain personal and professional integrity, and of course everyone's right to go ahead and develop in his or her career. Now, second, conceptual clarity. First was moral, now we move towards conceptual clarity. Be clear about the concepts. Professionalism requires being a faithful agent of one's employer. This is the concept. Now we need to have its clarity. But does that mean doing what one's supervisor directs or doing what is good for corporation in long run? Sometimes you may come across problems that your supervisor may say, ask you to do something which may be good in the short run, in the short run, maybe in upcoming 6 months or 1 year, but in the long run, after 5 years or so, that can be harmful. So the problem is, well, should I follow the short run of the supervisor or the long term benefit of the company? These might be different things. In particular, when one supervisor is adopting a short term view, that could harm the long term interest of the corporation. Now, moving forward with the conceptual clarity, again, what does it mean to hold paramount the safety, health, and welfare of public? In the case at hand, it means in the chemical engineer case, does it pertain to all threats to public health or just serious threat? And what is a serious threat? Sometimes there can be minor threats, but of course, for those minor threats that are less harmful, the projects cannot be stopped. So we also need to have clarity whether that is a minor threat or a major threat. Again, does being objective and truthful simply mean never lying, intentionally stating a falsehood? Or does it mean revealing all pertinent facts and doing so in a way that gives no preference to interests of one's employers over the need of public to be informed of hazards? So these are confusing concepts. We like you being engineer have to have clarity of these all concepts before you are able to make a decision of a case. Primarily, investigations convince the engineer that the company should implement stronger pollution controls, but her supervisor tells her that the cost of doing so is prohibitive and that technically the company is in compliance with the law. She also scheduled to appear, the engineer, before town official to testify in the matter. So the problem is, what should she do? She means the engineer. So she wanted to control, but her supervisor says, well, the cost to control is too much if they actually control, but they are meeting the government criterion, so technically there is no problem and they can go ahead with that amount of the liquids being poured into the sewerage of the city, and technically they are right. And the engineer is now called to the town official to certify that the amount of chemical being put into the sewerage is according to the standards of the city government. Now, number 4, informed about the options. Right? Previous was informed about the facts of the case. This one is informed about the options, that the engineer should know or should be aware of more than one options that can be taken in that particular situation. There may not be 100% yes no situations in real life, that either you do this or you do that, whereas one should be informed about maximum options, if not all of them. So consider all realistic options. Initially, ethical dilemmas seem to force us into a two-way choice: do this or do that. That is the initial stage, but we need to find more options as well. Either bow to a supervisor's order or blow the whistle to the town authorities. Well, blowing whistle is again a term in professional ethics. We'll see. It means telling some secret information to others. Right? We will discuss this blowing the whistle concept in our upcoming lectures, but today we can say, well, if the engineer goes out and tells the authorities that our company is doing illegal thing, then it means the engineer has blown the whistle. So either how to bow to supervisor's orders, means either follow the supervisor's orders or go to the authorities and inform them. A closer look often reveals additional options. Right? If the case is understood properly and in detail, so we can come up with more options, that there are not only two options, either to follow the supervisor or to go and tell everyone, even when is not even sure. Sometimes writing down the main options and sub options as a matrix or decision tree ensures that all options are considered. So we will learn it as we move forward with line drawing and flow charting techniques. We will see how we can tab all the options. Continuing with informed about the options, the chemical engineer might be able to suggest a new course of research that will improve the removal of lead and arsenic. This is possible that the chemical engineer can do some research and come up with some new findings that can help removal. Or she might discover that the city's law are needlessly restrictive and should be revised. This is also possible, that the laws city has given, they are not workable, doable. Perhaps she can think of a way to convince her supervisor to be more open-minded about the situation, especially given the possible damage to the corporation's image if it should later be found in violation of law. She can also convince her supervisor if she thinks so, that the supervisor is wrong. So these are all possible options. Unless an emergency develops, these and other steps should be attempted before informing authorities outside the corporation. A desperate last resort, especially given the likely penalties for whistleblowing. One should not just right away, without considering all these options, go to the authorities and inform them that our company is doing something illegal, because there are negative effects of whistleblowing. We will discuss them when we cover the topic whistleblowing. Now the fifth one is well reasoned. Make a reasonable decision. Arrive at a carefully reasoned judgment by weighing all the relevant moral reasons and facts. So facts have to be kept in mind, moral reasons have to be kept in mind, theoretical framework has to be kept in mind, and professional code, like in our case PEC code of ethics, has to be kept in mind. This is not a mechanical process that a computer or algorithm might do for us. Instead, it is a deliberation aimed at integrating all the relevant reasons, facts and values in a morally reasonable manner. As I have been saying since the first class, first lecture, that moral problem solving is not a mechanical process. It's not like a computer algorithm that you find 100% result. So there are many factors that have to be kept in mind. If there is no ideal solution, as it is often the case, we seek a satisfactory one, what Herbert Simon dubbed satisficing. So if there is no ideal situation, we take another situation which may be closer to ideal one, but it is workable considering all the factors. Now we move towards two analysis techniques. First is line drawing, second is flow charting. Let us begin with the first one, line drawing. Line drawing is useful for situations in which the applicable moral principles are clear, but there seems to be a great deal of gray area about which ethical principle applies. So, if this is the situation, line drawing is a better option. Polar opposites are established in line drawing. We will just see polar opposites, two opposite sides. We will see in the next slide. Positive paradigm is the one polar part, one end of the line, and next end of the line is negative paradigm. Again, we shall see as we move to the next slide. Moral problems are placed along line in accordance with where each fall on a continuum. That we will see if those moral problems that are on positive paradigm, they will be placed to the positive side, and those that are on negative paradigm, they will be placed on the negative side. P is place where you believe problem fits relative to entries. So P, you can say, is your decision. If you think that positive paradigm is acceptable solution, then you will be placing P towards the positive paradigm, or if you think negative paradigm, then you will be placing it to negative paradigm. We shall see these all points in the next slide. Now here we have elementary line drawing. We draw this line, and one side is negative paradigm, short form is NP, and the other side is positive paradigm, and the short form is PP. Now let's see example problem 1. Dispose of slightly hazardous waste into lake. This is not the same case, it is different. This is not the one that we have just covered. Water source, like the problem is dispose of slightly hazardous, slightly harmful waste into lake. Water source for nearby town, that lake is water source for nearby town. EPA limit 10 ppm of that waste. Average concentration of disposal is 5 ppm. If it is 5 ppm, then there will be no health problems. Persons will not even be able to detect the compound, like the water taste is not going to change if that chemical is up to 5 ppm. Dump 5 ppm waste in lake, harmless but unusual taste. Right? If they dump up to 5 ppm, there is no harm going to be for those people, according to this case, who take that water, but the taste might change. Town's water treatment system can effectively remove waste up to 5 ppm, so they say let it go. Town can remove waste with company purchase equipment. Well, if they don't want to spend public money, then company can buy an equipment for the town which can help them overcome this taste problem. This is another option. Town can remove waste with taxpayer purchase equipment, either company purchase or taxpayer purchase equipment. Occasional real illness lasts for an hour, sometimes occasionally, not frequently. At 5 ppm, people get fairly sick. This is another counter option. Lasts 1 week or longer term effect. This is, they can get sick. 7. Special equipment can reduce ppm to 1. So it can reduce ppm from 5 to 1, and if it happens, then all these major issues will be dealt or taken care of. Now this is how we will be placing these points. We numbered these points 1 to 7, and according to this line drawing technique, we say that point number 6, 5, 4 and 1 they fall in negative paradigm, and which would say that okay, they should not include that 5 ppm chemical in the drinking water lake, and point number 7, 2 and 3 like they are in favor that okay, no problem, even if it's done, then it can be treated with, and it's all right. So this P shows this P tells that they should go for positive paradigm. The final decision should be positive paradigm. So when we will be actually doing case analysis, keeping ethical theories, PEC code in mind, so maybe this thing will be clearer. So this is just the idea how to how to use line drawing technique, but we will actually practice in upcoming lectures. Now second technique to resolve the issue is flow charting, right? There are certain situations where flow charting should be used. Number one, it is helpful when there is a sequence of events in a series of consequences that flow from each decision. In line drawing, all options were available, so we plotted them on the line. But in flow charting, these decisions are connected. Unless we make first decision, we cannot go for second, and unless we resolve second, we cannot go for third. So if there is a case where there is sequence of events, then flow charting is a better option. We shall see an example. Give a visual picture and readily allows one to see results of each decision. We will see how flow charting gives a visual picture and how it allows the viewer to see the each decision. Like this is how usually a flow chart is. Like they start with the first operation, then they make the decision, then if needed they go for the second decision, so on and so forth. So we can take an example, like example problem 2, should Union Carbide build a plant at Bhopal? Like this company wanted to build a plant at Bhopal and they want to make a decision. So in this example we are considering only 3 areas to reach the decision. Number 1 is laws, number 2 safety standards, number 3 cost consideration. So let's see a flow chart that covers these 3 problems. Okay, so Union Carbide flow chart for Bhopal. Now see, we begin with the problem that this company wants to build a plant in Bhopal. That is at the top, the first thing. First step, are safety laws in India as strict as in US? If the answer is yes, then the flow chart ends here. They say design plant as in US. But if the answer is no, then the second question arises, are local laws adequate for safe operation, local laws in India? If the answer is yes, then they would say okay, design according to local standards. But if the answer says no, then there are 2 options. Like the first one, decide on minimal standards that will ensure local safety and build the plant anyway and assume risks. Then the next question would be, is this cost convenient? Like making these minimum standards and ensuring local safety. After having done this all, is it cost effective? After having invested in all those areas, will the plant be economically viable, profitable. If they say yes, it will be profitable, then they would say, okay, go ahead and build plant. If they say no, then the answer for this flow chart will be that instead of investing in Bhopal, invest elsewhere. So this uh, flow chart has helped them reach the decision uh, in at multiple steps. All right, so having covered both analysis techniques, line drawing and uh, flow charting, uh, you might be thinking of this question: which analysis technique should be used, either line drawing or flow charting? So perhaps as discussed in above slides, that there are particular situations where line drawing would be more effective. For example, if you have complete information about the case and all the points that are needed to make the decision are clear, and you can plot them on the line, and you can have positive and negative paradigm, and you can reach your decision. So in such a situation, line drawing will be more effective. But if there is a case like building a plant in Bhopal, where each decision is based on the previous decision, like all points are not clear as in case of line drawing, but you need to find out answer for the first problem, and then if it is resolved, all right, or then as a next step you go for the next option. So if your options are stepwise, one after the other, then flow charting technique is recommended to make decisions for such ethical issues. So I hope these problem solving techniques are clear to you. If there are any questions, any clarifications are required, please go through, like listen to these lectures. I'll also upload the PDF files. Please go through them and note down your questions, so that I will do my level best to address them in our live session. So thank you very much, and take a very good care of you and your family members. Please stay safe. Thank you.